Hi, everybody. Thank you for being here today. Our session today is moving mission-critical applications from one region to multi-region active-active. And before going further, this is the largest re:Invent yet, and we've had more sessions or breakouts to choose from, and thank you very much for choosing ours today. Here's some things to expect from this session. Today we're going to talk about the architecture and how we deliver services across regions for AWS. We're going to talk about when do you make the decision of moving from one region to multi-region. And we're also going to talk about some applications and services that already exist that help you move from one region to multi-region active-active. And I'm very happy today to have Sony PlayStation here with us as well. So we have Dustin and Alex, who are both senior principal engineers on Sony Interactive Entertainment. And they're responsible for delivering the experience behind PlayStation and PlayStation Network. So let's talk a little bit about global infrastructure for AWS. I know we all know what a region is, but I just want to look quickly at this. We have 14 regions globally today, and 4 more coming in the next year. And I want to look just at the Virginia region, just to kind of see what it looks like. So in Virginia, we have 5 AZs, or availability zones, and these are all connected through a high-speed network. And in our talk last year, a couple years ago, we disclosed that it's 25 terabits per second between AZs. So we're used to operating at a very high bandwidth, high availability model. And inside of an AZ is multiple or single data centers. So you can get high availability applications just by deploying them in that model alone. And it's up to you. You can choose how you deploy your apps, whether it's single AZ or multi-AZ based on your requirements. And here's some region-wide services that you can leverage existing today across the entire region. And these services are already delivered across multiple AZs. So Amazon S3, EFS, our NFS file system, is across all AZs. RDS for database, our NoSQL offering, DynamoDB, and also others. So when do you choose multi-region? So as an enterprise architect here at AWS, we talk to enterprises who run their own data centers already. They're used to operating maybe multiple DCs, and they say, hey, I've always run more than one. That means I need more than one region, right? And it may or may not be the case. So here's some cases that we see for patterns to decide on going to multi-region. You may want to lower latency to a specific subset of customers. So for example, US-based customers get service from US-based regions, and it depends on the geographic that they're coming from. They get service from local regions. There may be requirements for data sovereignty to keep data within a specific country or area. And when you place data into a region, we don't move data out unless you specifically move the data. And another reason that we see some companies have requirements for separating data up to several hundred miles away from one another. And this could also solve for that. So I want to talk about some existing multi-region services that help you move from existing single region to multi-region. So this includes services like Route 53 for managed DNS, S3 using cross-region replication, RDS with multi-region database replication as well, and more, such as EBS snapshot replication and AMI replication. So with Route 53, we support health checks where you can send traffic to healthy environments, latency-based routing, which controls the ability to say a user gets routed to the region closest to them, regardless of where they are globally. You can get tighter with GeoDNS and say anything from this specific country or region gets routed to this endpoint, if you need to. And round robin. And this serviced out of 68 POPs, or points of presence, globally today, and that's constantly increasing. And Route 53 works with non-AWS endpoints as well, so you can use it with your existing environment if it's on-prem. Here's topology, what it looks like with the setup we talked about. So we have example.net, and on a health check, if infrastructure is not healthy, we can route traffic to a static website, for example, on S3 that says traffic's under heavy load right now, or come back later. And assuming it passes health check, what we're doing here is we have 2 regions. We have prod 1 and prod 2. And you can split with weighted round robin to say 95% of load lands on prod 1, where 5% is on prod 2. So for example, if you're going from 1 to 2, you don't want to necessarily split traffic in half because you might not know what the situation is going to be on the other side yet. So this allows you to easily test. With S3 cross-region replication, when you write an object to an S3 bucket, you can have a target bucket that the object gets replicated to, and that could be in the same region. It can be in a different account if you need to for compliance reasons, and it can also be across the world in another region, another bucket. And what I think is fascinating on this is we manage this for you in the back end. You don't have to worry about any logic to move data between S3 buckets. This is all done automatically in the back end by AWS. And the data class, it doesn't have to be S3 standard. It can be S3 standard on one side and infrequent access on the other. So you have the decisions on how you want to place data and what storage class. And you can also transition S3 ownership between accounts as well, because you can write to an account that's outside of yours if you have to. And with RDS cross-region replication, you can move data closer to endpoints. So for example, you have a master database residing in US East and have read replicas across the world to enhance the user experience that's closer to their area of the world. And you can also promote read replicas to masters as well. So if you have a failure in one region, you can easily promote and keep running. And again, it's an AWS managed service. So that's kind of what it looks like. So you have a master database in, let's say, Virginia, with replicas across the world. And it's very, very easy to deploy this. And again, we do the heavy lifting. And there's many existing resources that you guys can rely on, right? It's not, you don't have to recreate the process as you go down this. Like there's many before you have taken this journey. We have many existing pages on reference architecture you can refer to. And we have white papers and documents and a vast ecosystem. And something also I wanted to point out, all AWS customers have solutions architects like me, regardless of your level, a personal account, you can have an SA you can talk to. So please leverage the AWS resources who are here to help you with this process. So we talked about the architectural background, and we saw some theory on how you can do it. And it's with my honor, I'd like to bring out Sony to talk about how they've actually done this journey for the PlayStation Network, moving from one region to multi-region active-active.
I'm ready to go. Hey, let's get together and we'll lose control. You know what I like and you know I want some more. Don't stop, don't stop. I can't get enough. I love it, love it, love it. Let's keep it going on. I can't get enough. I love it, love it, love it.
Now starting at $299.
PlayStation.
So did you all see that great deal? I mean, that's incredible. You can't beat prices like that.
Still available on Amazon.
So when you buy one, you're basically funding us too, paying us directly to our pockets. So who are we?
I'm Alex. I work
I'm
for
Dustin.
Sony Interactive Entertainment.
Yeah, so we work for Sony Interactive Entertainment. We do a lot of cool stuff, and I wanted to share with you our active-active story. Kind of give you some background about just our team in particular in the San Francisco office. We started out as a very small team with a really large responsibility. We ran pretty much like a startup. We were essentially less than 10 core people working on the new PS3 store. And the user base is already really huge. They're already used to using the PlayStation Store on the PS3 and on the Vita. And we want to really increase that presence and increase digital sales. We want to have an online web store, all these things. And we really relied on quick iterations on AWS. It was super important to have quick iterations of changes in architecture to make sure we scaled out to the user base that we had to deal with. So some of the things we do. So for example, we do social features. So for example, we have friend search. We have your activity feed. So basically, think of it as kind of like a hybrid of like Facebook, Twitter, those kind of things. And we provide services when you play a game, when you make friends, if you earn a trophy, you get to share it on PSN. Also, we have communities. So we recently released this on mobile, and it lets you build your own game forums. Yep, share communities with other users. For video, we do things like Amazon video services. We sell video, we get to stream video to the console. We do live streaming television to the console, to laptops. Very cool stuff. And like I mentioned, we do store. And one real cool thing, really cool slide here, is it's the year of VR. And PlayStation VR is slated to be one of the most popular VR systems out there, and we're on board on that. So kind of tell you what was going on with us. When we started, the store was like this, low resolution graphics, and it was pretty bad, and we transformed it into a very interactive digital store and to allow games to really showcase what they have. And what was cool is when we did deliver it, and the execs were saying, okay, you guys did a great job, why don't you now do some services for the PS4? And that's what our team got to be privileged to work on. So PS4 launch, give you kind of perspective of how we had to deal with scale, is that we had 1 million users at once, day one, hour one. We had to be able to manage that kind of scale. And we had to design for many different use cases at scale. So all that social aspect, all the commerce aspect, all those things had to be done at a large scale for large user traffic spikes. So now that we did that, we are evolving. So if you think about our architecture phases, this is a very typical of a lot of companies, is that you start with a proof of concept, you want to scale it, you want to optimize it, and then eventually you want to make it highly available, and eventually you want to make it more efficient. But let's talk about highly available today. So next step to make it highly available. So there's a lot of ways to define highly available. For us, it was multi-region active-active is what highly available was for our team. And it really raises a lot of key questions. For example, how does one move such a large set of critical apps? So apps that are providing experiences for the store, for interacting with gamers, all these had to be moved with hundreds of terabytes of live data had to be moved. How do we architect every aspect of this to allow for it to be multi-region active-active? It introduces race conditions, all these kind of different things we had to account for. And how do we do this without affecting users? We don't want to say, hey, guys, you're not going to have PSN for a week while we're doing this. We need to make sure that it's done without them noticing. And keep in mind that this user impact is more than just for the gamer at home, but also the game publishers. They are also expecting our services to be live all the time. So the question is, where do we even start with this? I think Alex will have a good explanation of how you can build your step-by-step process in migrating a bunch of apps.
Thank you, Dustin.
Yep.
For pre-warming folks. Right, so we decided to start with most important at this point in time, applications. You're probably thinking that I'm gonna do what a lot of folks do, just give you a recipe, how to design a system so it can be scaled and deployed in like 100 regions, and then we be highly scalable. I'm not gonna do it, and the reason is it's kind of a tough problem. It's actually really hard to cover it even in 1 hour sessions. There are too many moving pieces. Also, every single application is different. We have our use cases, you saw, right, how many things we do. Some companies do only one thing. We do multiple things. So there are different use cases, different applications. My analogy usually, let's say we're talking about a car. If you buy a commute car, it will be it probably will be something reliable, not very expensive. If you want to go to a racetrack, right, you want a sports car. And then if you're a professional racer, like F1 car, will be a good choice for you, right? You're not gonna race Formula One in a Honda, right? I hope you will not. Cool, on the same page now. So the first question, what does it mean to be multi-regional? Dustin kind of said that, okay, yeah, we decided active-active. It wasn't easy for us to decide, to be honest with you, originally. And then just because, diversity means different people, different opinions. So some people said active standby is good enough, right? If there's a problem, we just shift the traffic. Done. Some people said active-active is the way to go. Yeah, also pretty fair. Another thing to think about, how do we replicate data, right? If some folk, hopefully someone attended our soft state talks. Anyone? Yeah. So you know, right? So we use soft state pattern, we use stateless pattern. There's data involved, so we need to figure out how to replicate data. We have multiple storages. Also, failover. Should it be automated? Should it be manual? All those questions, and there are many more questions actually. So, after some very healthy discussions, no one got hurt during them, but we decided that we came to some kind of agreement. We decided that we should be able to lose one of anything, which means we should be able to lose one server, one availability zone, one region, right? Something very simple. It's more complicated if you think about it, but we decided, okay, here's our guiding principle, and if you stick to them, we will be able to architect the system or look at the system and figure out how we can move pieces without breaking the principle. So now think uncertainty phase. We have multiple micro and macro services. Some applications are monolithic applications. I know the pattern is go microservices. It's not that easy, right? We have legacy. Those apps, we can't just remove them, rewrite them. It's hard. It takes time. We needed to do something. Some services are stateless. Some use soft state. Some stateful. Yeah, we had stateful services. Shame on us. But we did. So also another catch, those applications, they depend on multiple technologies behind the thing. There are databases involved, messaging queues, all those things. Some of them are multi-regional by design, and some are not, right? It's reality. And then documentation, right? It's a standard state, almost out of date. So we have to figure out how to even find what should we move, how should we move it, what is the scope of work, what do we do with inventory. So it gives this thing gives you an idea. You can see that like we really heavy on Cassandra usage. We use SQS, Redis, Kafka S3, Solar Cloud, and Solar 3. And a bunch of other things, and some I didn't mention because it will be just too much on one slide. So we have all of this and a bunch of microservices and services talking to those things. And then after we went through the list, we asked, okay, what is multi-regional by design? We have so many things. Should be easy to move, right? And then S3, right? Multi-regional, nice. Cassandra. Another multi-regional thing, Apache Kafka. You see, it's kind of occupied whole slide, so you can guess that that's it. Even with Kafka, it didn't work for us right, like in the way it is right now, available as an open source. We had to do some customizations to make it work for our use cases. Right. So stages of grief. Anyone heard about it? All right. Denial. Can't be true, right? Let's check it again. So we checked it again. Reality is an interesting thing. It doesn't change when you want. Anger. Yeah, right. So the idea was that a couple of years ago, I kind of told everyone, hey guys, we want to go multi-regional. Yeah, please, when you design, when you develop things, make sure we can easily move it. There's a human nature, unfortunately. When you say something, when you want something to happen, but when there is nothing pushing you, right? It's not going to happen. It's a big problem with the old component approach. You can design really good, very beautiful system, and then when you start implementing, sometimes you do some hacks, sometimes you don't have time, sometimes you need to do really, really quick hot fix, and then you forget to remove it. And then you ended up with something that it's not a component. You don't have components anymore. You have this mess. So, and then what's actually interesting, even my code, when we moved it to multiple regions, I found a bug in it. Just can you imagine? It's crazy, right?
Unbelievable.
Yeah, I couldn't believe it until I fixed it. Good thing we have a good monitoring, so we caught it early, but it is what it is. So, another stage. Maybe we do active standby. Maybe we should review our guidelines. Maybe it's just maybe too hard. Maybe we just cannot do it at all. Right? Active is only for us, big companies with huge budgets. I don't know, Google, some like huge ones. But finally, we got to acceptance. The acceptance is, right, we have all of it. And then we have 6 months. Like, doesn't matter what we think, we need to do it. And what it tells us, it told us that we cannot just put things together, magically and move it and put it in different regions and then it somehow works, right? It's not going to happen. Even if we want it really hard, it doesn't. It just, things don't work that way. And then we just need to start thinking. We needed to start thinking about it and thinking what we should do. And we came up with several ideas. First, migrate services to technology which is multi-regional by design, like pretty obvious. Your database is multi-regional, you're stateless, you're good. Or probably you're good, right? There are edge cases. And there's another solution. Let's somehow make the underlying technology multi-regional, which could be even harder in some cases. Like making MySQL multi-regional, active, master, sounds like a challenge. Also, right, we have all the things, services, microservices, macroservices, all those technologies. We have infrastructure that we need to do. It's not infrastructure piece that we need to do. How do we even schedule this thing, right? How do we figure out what steps we should make? And it's work that should be done no matter what. And then we had to somehow figure it out. And then also, it's kind of optimization problem. We're not managers, we're software engineers, so we approached it as optimization problem, right? How do we schedule things like a multi-threaded application so it can complete in the fastest possible way? And also, we wanted machine to help us. So the reason we wanted machine to help us is because when I was originally asked what should go first, I said, all right, this app and that app because I use Cassandra, and I was wrong. And I was wrong because machine later said that I was wrong. And I had to admit, again, to denial. I went through another 5 stages. So how did we do it? I spent quite a time talking to people, like an hour, like asking, hey guys, like managers, how do you do it, right? You should be doing it every single day. Then when I got desperate, I used the last resort, Stack Overflow. Yeah. Nothing, right? Maybe I was using different words. I don't know. Couldn't find anything. And then I thought, oh, it's like a graph problem. Do you remember yesterday I said on Monday that Friends Finder, it's not a graph problem. But that is. How come? It doesn't look like a graph problem. So it is. And we used Neo4j database, a really good one, open source one, you'll see why, to help us to solve this puzzle. So, why Neo4j? It's a graph engine, and we're dealing with a graph. You'll see why in a minute. There's a core language, quite powerful, can do magical things, especially if you use Stack Overflow. And Google sometimes, this can be populated programmatically, and it's really important. And also, it can show us something we don't expect. It actually helped us. How can we use it? So, well, very simple, right? We need to create a model, come up with a model, identify nodes and relations, and then how do we do it? In this example, nodes are our microservices and pieces of technology. And then we can use tracing to find all the relations, right? We can use zip keying, open tracing. It can help you to to see that application A talking to application B, and then they both talking to maybe Cassandra, and then another way is just run code analyzer. It's not really, code analyzer will not help you much, but it might help you to just double check. And then last resort, talking to people. This one is unreliable. If it's really big, you'll spend a lot of time, so maybe to double check, or sometimes when you cannot apply any of those, you'll have to do it, right? Sometimes even engineers will have to talk to people, yeah. And then you generate this graph, run queries, and then it gives you the answer. So, some example. Nodes, users, technology, Cassandra, Redis, in this simple example, and then let's say we have a simple property, multi-regional, true, false. Services, applications, let's say they can be stateless, true, false, and different ages, like usage patterns. Let's say it's read-write. And so if we take it, we can create the simple definition, right? It's Neo4j. You'll see it later. You can download it. You can make a photo. Yeah, wait. But the idea is, this is language that you can use. And then when you run it, Neo4j is going to give you that thing. And then it shows you, in this example, PlayStation 4 talking to app 3 and app 1, which talking to app 2, and then app 2 talking to Commerce Cassandra cluster in this example, and app 1 talking to Redis. Our blue Cassandra is marked as multi-regional. Our Redis marked as not multi-regional. And then it's very simple. It's very nice. Ours look like that. Something like this looked scary in the beginning, but not that bad, honestly. So we ran another query. So this query, what it does, it finds all the nodes, all the applications. It depends only on multi-regional technology. Right, this parameter is important. You can tune it. If you say 2, it will show you something that depends on 1 on multi-regional, and so on. If you run it on a graph, it gives you that thing. Right? So both depends only on Cassandra, so we're good. So what did we do next? We had to validate that our multi-regional technology actually work. People say yes, but does it? How do we know? And figure out what to do with non-multi-regional ones. And then, after we do it, we can move services in a following order, another magical query. It just sorts applications per number of non-multi-regional technologies. And then the idea is that we just went from up towards the bottom and moved one by one. That's what we did, actually. So how did we validate stuff? Our main database is Cassandra. We use it a lot. It was a lot of unknowns. Will it work? How about performance? Will we see any degradation? Oops. Cassandra is eventually consistent database. How eventual is it? What will be the latencies? Any roadblocks? What kind of roadblocks? Because then they're always there. And then we knew that Netflix did it. And they doing it on AWS. They tested it. The way they did it, it was quite simple. They ran 1 million queries, 1 million inserts. They put it in Cassandra. They waited 500 milliseconds somehow, I don't know how, but exactly 500 milliseconds later, read it, and they say all records were successfully read, so they said, we're good. Well, some questions that we had to answer. Should we just trust Netflix results? Should we? No, yeah, good. We should not. We should not probably because there are different use cases. Just to give you one example, there's today or tomorrow talk about how they move from classic to VPCs, right? There's some issues that they probably gonna face or faced. And another question, is the experiment even applicable, right? And now the last one, can we do better? And we can. We definitely can. Our strategy was simple. We want to use production data, production load. We want to simulate disruption. We want to know exactly what happens when Cassandras cannot talk to each other. We want to track replication latencies. I want to know exactly how long does it take for a message to go from one region to another region to a third region, right? And what happens when there's a conflict. And I want to see what's going to happen when we lose mutations, when we write. And unfortunately, we had to modify Cassandra. And if you're actually interested in how we did it, there's a talk on YouTube from Cassandra Summit. Like, goes really in deep how we did it. But high-level overview, we took production Cassandras, fetched all the data from it, and we put it on S3. Then we used ingester, which fetched data. We ran them from different regions. We put them in Kafka. Why Kafka? Because we use Kafka. It was available. And then we can, if you do it, you can use Kafka to later replay all this data. You can control. It will be controlled experiment. You know, insert rate. You can do reads. You can do wherever you want. You can do multiple threads, and you can do it. You can do same experiment multiple times. Later, when we're ready to run it, we just use a Kafka read thing we called read-write loader to put some data on a test cluster. Test cluster was modified, so it was writing. It was writing some metrics to Amazon Kinesis Firehose, which was delivering them to S3, right? And later, when we ended up, after multiple test runs, we ended up with a lot of data sitting on S3. Data was very simple, like mutation Y arrived from Cassandra server B, and it took that many milliseconds. And data size was there was another field that showed us how much data we transferred, things like that. And later, from S3, it's really easy to actually use Spark and AMR to crunch data. So it gave us at the end something like that. So this one, it's a graph. It shows you latencies. It's experiment with disruption. We modified security groups, so we cut the traffic between two regions. You see replication latencies, and then the reason you see this square is because it took some time, right? We waited for an hour, and then once we opened it up, data got replicated. So how about things that are not multi-regional by design? We gave teams two options, actually. If it's critical to users' experience, they must be redesigned. If not critical, like bad jobs, so there are several options. Like active-passive is fine if we can actually restore it really fast. Master-slave, fine as well. And use Kafka. That's what we recommended, but it was up to the teams, because actually team knows the best what's good for their application. It's really hard to dictate it. And then here's another example, Solar example, pre-active-active. A very simple standard architecture, indexer, Solar master. It's Solar 3.0, so you can see that we use replicators and then read replicas, and then applications. Applications talking to read replicas. Right? Simple design, everyone knows it. So simple active-active, right? We take that thing, and then we just use replicator to replicate on another side. One choice, if you don't have time, it will work if you can rebuild indexer really fast. Another one requires a little bit more work. We offered like to put Kafka in between, change design drastically, but it allows to do bidirectional replication using Kafka. You can now index from both regions and insert it in your indexes. So that's just two examples. We had many more examples. We had MySQL. We had many things actually that we had to go through. But it gives you like just an idea how you can approach the problem. And then you're probably wondering, are we missing something? Anything? Anything I forgot to mention? No? All right, we're done. So infrastructure, right? We cannot just deploy it. If you don't have anything in another region, you cannot just drop stuff there. It just doesn't work that way. And Dustin's going to cover this important part.
Yes. Magical infrastructure. Just throw in the cloud, it will work. That's how it works, right, guys? All right, so what we want to do is decompose and recompose our infrastructure from one region and recompose in the other region, right? So what we want to do is first break our infrastructure up into movable parts. This is kind of a typical architecture that you may see. You have your different layers. You have your private subnets, your public subnets, your outbound tier, your inbound tier. You have your data tier, your caching tier, and your clients interact via some entry point. In this case, maybe an EOB in this case. So this is very typical. So what do we need to build in the other region? It's very typical stuff. The private subnet, public subnets, and we want to build the VPC subnets, all the network rules, all the internet gateways, NAT egress, all these that we need to build. And that's very easy. So key points about that is that building infrastructure that we decided that we had to make it fully automated. Our previous infrastructure was built very organically as our use cases came along. But now that we're going to be building multiple regions, we had to make sure that we could quickly stamp out into region 2, region 3, region 5, 10, 11. It doesn't matter. But the point is, it had to be infrastructure as code. We would not allow it to be built by hand. And there were some questions. Like, there's some key decisions that we had to make was, how do we do cross-regional communication? Do we use VPNs? Do we go over the internet? How are we supposed to do that? Do we do it for every piece of the infrastructure? Do we do it for our apps? Do we do it with our data? Those are some key decisions we had to make. And the big question is, do the infrastructure have to match exactly? We're building active-active. Should region 2 look a lot like region 1? Should it be completely different? Should there be some comfortable middle ground? And like I said, the first one was basically organically grown. So the second region should be a blueprint for every new region. So we had to find some kind of comfortable middle ground to have them communicate, and that we could still monitor them the same way and build the same way. So we had to do some compromises there. The next phase that we had to do was manage the data. Data is the key moving point. After you have your infrastructure, your core network there, you have to move your data. And there's some key questions about how we're going to replicate data. So Alex went over some scenarios, but the communication between it, how are we going to do it? So one way was let's punch a hole. We have our data in a private subnet. Maybe we punch a hole, throw a VPN, and communicate to region 2. There's some advantages to doing that. And depending on your use case, it may be the way to go. So for example, setting a VPN with our particular current network architecture was actually very easy. It wasn't that difficult to do. It was very straightforward to do. It was also secure. And because only our traffic will be going over it, nothing can look at it, no man in the middle, we can really trust the communication channel. And then also manage these data nodes is pretty straightforward. We don't have to think about what kind of IP a particular node has. It's all taken care of. There's lower operation overhead. We don't have to create new scripts to manage it. It should be about the same. But there's some serious cons. Some of the cons are that we're really limited on throughput. Depending on how much data you're creating, it could quickly saturate a VPN, something that we saw. And depending on what you're doing, maybe it doesn't make sense. And then also when you scale with more applications, now you only have a fixed set of VPNs you can use. If you add new applications, maybe it works for you today, but maybe tomorrow you're adding 10 new applications, it may not work. So it's something to keep in mind. The second phase, again, this same phase, is another option is that maybe you go replication over ENIs with public IPs. So basically move your database into a publicly accessible area and then have them communicate over SSL, some secured channel, to the other region over the internet. And there's some really good things here, right? So some of the pros and cons here is that now you're not network constrained. You can have petabytes of data being replicated, similar to the experiment that Alex was talking about. And then you don't have to worry about adding new applications. You're just going to do it just naturally, and then you've already created this very open communication channel between your databases. You don't have to worry about having to create new VPNs, create new things to handle your traffic load. But the serious cons are the operational overhead. There's a lot of things you have to do to make this happen. For example, the Cassandra example is that you have to make sure that each node has an elastic IP, that they're aware of each other in multiple regions. There's a lot more operational orchestration that has to happen to make it work. And another thing is that the internode security must exist. You have to make sure that the data channel is truly secure and that nobody can just listen in the middle. So and some technologies may not allow this. I think in some cases you'd have to even create some kind of secure proxy to make it happen. And then we needed also an app tier and caching strategy. How do we want to manage how apps talk between regions? We took a very simple approach. We said, you know what? How about we just don't have apps talk across regions? Why don't we make sure that app from region 1 does not talk to database in region 2, or microservice A in region 1 doesn't talk to microservice B in region 2. So that's what we chose. We said communicate within one region only, and then call other databases or applications. And then why we did this is because this isolation was essential to make sure that our failure cases were predictable, and it clearly defines what the failure domains are. Because if you imagine having another region is more than twice the work. You have to monitor a lot more. Why add complexity when you don't have to? In our case, we said, we want to be able to monitor it and make sure that we can know exactly what is happening at all times, and we can really debug things when we really have to. Our client routing, very simple. Call DNS to see where you want to go, sticking them via geo, and then call it to the different region. Very simple, very easy to know where your particular user is. If you're from this country, you go to this region. You're in this other country, you go into this region. So let's go here. So predictable. It had to be very predictable, sticky routing. User customer complaint, we should know what region to hit. We can now know that our failure zone is isolated between one region. We can then track down what the problem was and figure out what's going on. And basically the state that's maintained, we just say, okay, now that we have user sticking to a region, it's fine. The data is replicated in our data tier, and that's going to be managing the state. And then if we do that, we just have stateless services, all magic happens, and the user is fine. It doesn't matter what region they are, but they're stucky. And we're able to do some form of percentage-based routing, just based off depending on what country, we can put into a certain region. We can know generally how many users are going to what part. So let's say we're putting it all together. So one key thing is that you should make sure your software design is capable of multi-regional deployments. And this is your typical software architecture. You have your API, business logic, data access. Everyone has the same design. It's nothing special. But I want to focus on two key components: is the data access and the configuration. So remember when I said that multi-regional deployments, that they had to have application patterns like this, where application 1 couldn't talk to region 2. This application couldn't talk to this database. And we want to make sure that within a region, the apps can talk to each other, and within a region, the application can talk to a database. So how do we achieve this? So this comes down to the way we manage our configuration. For example, an application configuration to a database could look very much like this. For example, we could have our application who wants to talk to Cassandra seeds. It's talking to a set of IPs. And I think a naive approach would be to just have the multiple configs per region. So you can say, my apps that are deployed to region 1 are going to have this kind of configuration. Apps that are deployed to region 2 are going to have this configuration. That could work, but that actually creates a lot of complexity, right? So now what's going to happen is that you're going to have to manage two separate types of deployments, two different builds potentially, weird kinds of ways of configuring your application. And it's going to quickly make your deployments infinitely more complex. So what did we do? What if we implemented some kind of basic form of central configuration, or a way to look up the things within a region when you need them? So for example, let's say we had some kind of region local DB. So where are my Cassandra seeds? Okay, I'll tell you. It is these IPs, and then your application can know. So now your region's telling you what your application needs to do. And in our case, what we did was that we basically use Route 53 in a lot of places for internal lookups for our applications. So for example, I can ask for some DNS name saying Cassandra seeds 1, and then that configuration is the same in my application in region 1 versus the same configuration in region 2. And then the Route 53 is configured in each one to tell the application where the Cassandra seeds are. And the same thing can apply to all your different microservices. So for example, microservice B needs to talk to microservice C, as opposed to putting a load balancer name inside the configuration. You would then reference that DNS short name and then have Route 53 tell you exactly where to go within your region. What this really does is create this really great isolation within the application, so it doesn't need to talk out. Okay? So then it results like that. So the key thing about the simplified software configuration is to make sure that the application contains some kind of context which the infrastructure manages. So for example, it should have data center, it should have endpoint shortening resolution, so we can know what database to talk to, what microservice to talk to. It should have some kind of environment. It should also have some database connection details. And this is what is very essential for the application to behave correctly. And so basically, context is very responsible for the infrastructure itself. I mean, the infrastructure is responsible for how the application behaves based off of if it's in a certain region or how it's supposed to behave if you have dev environments in both regions. So we did this through a lot of the build automation. And so it's basically context driven. So in terms of infrastructure as code, we use Terraform to do this. Whoa, okay, let me skip back. So new regions had to be built with automation. So what I mentioned that before is that every region had to be a blueprint for the next one, which meant that we could never hand create anything. So what we did was basically focus on spec-based infrastructure. So what we did was we specified every microservice, and this would then feed into Terraform, and then this would then drive with how the infrastructure was built. And so we had an internal tool that was basically an internal tool and a DSL that which basically could manage our Sony-specific domain knowledge for our microservices. So each microservice had a definition, a specification, that then would then generate a Terraform, something to be fed into Terraform to build the infrastructure for that microservice. For example, let's say an app required Cassandra and SNS. Well, the specification that we had would then be able to generate something that would create security groups for ports 9160, or these ports from 7199, 799, to build an SNS, build an EOB, and all the infrastructure needed to support that microservice. So we had this for all the different microservices and let it so we can just really just print out all our different infrastructure for all of our different microservices. In terms of database automation, like I said, what we chose was to actually go the route of moving our private database, our database in our private subnet into our public subnet so that we can not be network constrained. And we used Ansible to do a lot of this automation. It was responsible for moving our applications to public subnet, giving it EIPs, managing our node list, and that's what we did with that, and manage our whitelisting between our two regions. So you can imagine now that we're talking over the internet, we have to make sure that our nodes can only talk with each other. And so with that, we're able to make sure we filled in that security constraint. It also was responsible for managing certificates in SSL, and that was key in our Cassandra deployments and also our solo deployments and all that. And another thing is, now that you have another region, now the monitoring is super key, and we have to make sure that we can monitor it and know where any problems would happen. So we use Grafana, which is here, and what's key here is that through proper tagging, we should know what any metric, where it's coming from, and how to aggregate it so we can show those pretty graphs in Grafana. So part of the context of all the applications, like I mentioned before, was the region. And with this region, we're able to attach this to all of our logs, or give this context to all of our logs so that we can then build our proper graph so we know where any problem exists. So these region tags are added, and we can just be plugged into any monitoring of your choice. We use Grafana, and we also use some Splunk. And then some of the key metrics to always be watching for, and like for our case was the data replication was actually super key to look at. For example, in our data replication, hints of Cassandra was a key metric to see if something was going wrong. Seconds behind master MySQL was another one. Kafka, just how many messages that are in and out that you've been processing. These were all key to figuring out if there was any problems going on in your multi-region deployment. So what here is putting it all together. So here we are, we're starting with one region, we're monitoring it. We have our applications in the public subnet, we have our database in the private subnet. And this is, we want to go multi-regional. So now let's see what we want to do. We first spin up via Terraform our second region with the infrastructure that we want. So the infrastructure doesn't match exactly. We have our database available over a public subnet. And it doesn't match exactly like our first one, but it's a lot more scalable to deploy this. And we deploy our databases. And we test this to make sure that our deployment automation works. And then we replicate. So after we replicate, we do what Alex was mentioning. We started measuring production data to make sure that our data replication was sufficient and that we could manage any kind of connection disruption. So we monitor that. And then we let it catch up. And then we then deploy our applications that we need. We run full testing on that side, not exposing customers to that tier. And we basically let the customers still talk to region 1. And then we just monitor. Then what we do is then we configure our DNS and our consoles to really to reference the DNS and then route traffic accordingly. So with this, each step of the way, we are monitoring each aspect. So what we do is we layer on the different pieces. We layer on first our infrastructure. We then test each part of that. We put our data on. We test each piece of that. We then deploy applications, test the functionality of that. We give a little bit of users to the second region, make sure that their experience is fine, and then we go full 50-50. And that's just a simple way of just layering on the different pieces of your multi-regional deployment. So then you know exactly that what you're delivering is of quality. So some lessons learned. So some lessons learned from this were this. So data synchronization is super critical. So the thing is, that is the number one thing you have to do. It is the dependency that every application has to go back to. So that when you build your dependency map, you just start with that first. And then from there, it should make sense. So you use the graph technique that Alex showed, and then it will show you the path of how to go multi-regional and what apps to deploy first. Second is always run your own benchmarking. So there's so much data out there. Like, for example, Netflix did their benchmarking. All these different companies have done their benchmarking, Uber. And you know, it is really good for them, but is it good for everybody? Probably not. It's not good. Depending on your use case, you should always run your own benchmarking. It takes a little bit more time, but it's completely necessary. And also, don't allow legacy to control what your next region should look like. It should always be some healthy transition. Don't let how you built things in the past define how you build things in the future. Don't make sure that your new regions don't have to match exactly. Make sure that you build exactly the perfect design to allow you to build multiple regions afterwards. Applications always have to be context-driven. Never let your application decide who they're talking to. Always have the infrastructure tell you that. And depending on your data load, cross-regional VPNs may work. Our case, it didn't. We saturated VPNs really quickly, so we decided to go, add some complexity to our system and then move away from VPNs. So we're hiring. We're doing a lot of cool stuff. You go here. This is, we'll go to either my or Alex's LinkedIn. So feel free to friend us. We're doing a lot of cool stuff, a lot of hands-on things. Multi-region is one of those things where you're going multi-regional with all our applications. So yeah, thank you very much. Appreciate all your time. Yep.